Symbolic addressing and branches. Assembly language simplifies low-level programming by allowing the programmer to use mnemonics instead of operation codes. Assembly language also allows the programmer to use symbolic addressing instead of actual memory addresses. A symbolic address is a label associated with a memory location. The assembler will calculate the actual addresses corresponding to each program label when it is translating the source code into executable code. If we take a look at the example program below, we can see that various memory locations are being used. They are accessed using their actual addresses. This makes the program very rigid and would have to start at memory address 600 every time. Also, any data that is being used by the program would also need to be stored at the exact location, as specified by the program. If we introduce symbolic addressing to our program, we gain more flexibility. The assembler will decide where to store the program at runtime, making sure to also convert any other labels into actual memory locations. In this way, the programmer does not need to worry about memory locations, and can use such labels to specify data locations and other parts of the program. These can be compared to variables and function names in high-level languages such as Java or Python. In assembly, like in algorithms and any other programming language, the programmer is able to perform iteration and conditional jumps. A branch makes this possible by taking the program to a different segment of memory to execute. Such branches can be conditional or unconditional. In the previous program example, we made use of both conditional and unconditional branching. JMP loop simply jumped to the memory location represented by the label loop. That is, it did not check any condition and would jump every time. On the other hand, JSFinish checked each time if the value within the accumulator was negative. If this was found to be true, the program would jump to label finish. If not true, the program would continue to execute from the next instruction, STA-N2. Thank you for watching.